Today I'm going to be going over the 5-4 and 5-5 notes. So 5-4 is on using the derivative first derivative test to determine relative extrema. So remember, extrema is the plural for extreme, minimum, maximum values. Minima is the plural of minimum. Maxima is the plural of maximum. So here's the first derivative test. Let C be a critical number of the function f that is continuous on an open interval I that contains C. If f is differentiable on that open interval, except possibly at C, then f of C can be classified as follows. This is really important. If f prime of x changes from negative to positive at C, then f of C is a relative minimum of f. If f prime of C changes from positive to negative at C, then f of C is a relative maximum. If f prime of C does not change its sign at x or at C, then f of C is neither a relative minimum or a relative maximum. So let's take a look at these diagrams here. Do you see that my slopes are negative? Okay, so f prime of x is negative, and then here my slopes are positive, so f prime of x is positive. So the derivative, the first derivative, is changing from negative to positive, so there's a relative minimum. Here my derivative is positive, the slopes are positive, then the slopes are negative, so there's a relative maximum. Then do you see this is positive and this is positive, so this is not a relative minimum or a relative maximum. Similarly here, that did not change. So let's get into it. So in example 1, it says find the points that are relative extrema of the function f of x equals 1/2 x minus sine x on the interval, open interval, from 0 to 2 pi. So here's what you're going to do. We're going to find the first derivative. So that'll be 1/2 minus cosine x. We're going to set it equal to 0 to find the critical points. I add cosine x to both sides. Now think about the unit circle. Okay, this is, I know, where we've struggled. All students take calculus. Cosine of an angle is positive in the first and the third quadrant. What would be the reference angle? The cosine of what reference angle is 1/2? Well, if you said 60 degrees or pi over 3, you are correct. So then I just need to, that is first quadrant, so that's great. And then my fourth quadrant value would be 5 pi over 3. So then here's what I do. I create a number line. Now this is on an open interval from 0 to 2 pi. And I have these critical points, pi over 3 and 5 pi over 3. So these are my critical points. All right, now we're going to do a sign chart. And you are plugging into f prime of x. So for example, and you can plug in here is absolutely fine. So I would do 1/2 minus cosine, and let's pick a value, let's say pi over 6. So that's 1/2 minus radical 3 over 2. Can you tell just looking that is actually negative? Then let's pick a value between pi over 3 and 5 pi over 3. So pi over 2 might be, sorry, it might be nice. Sorry about that. That's 1/2 minus 0, which is 1/2, so that's positive. All right, then let's pick a value between 5 pi over 3 and 2 pi. So let's say 11 pi over 6. So that would be 1/2 minus radical 3 over 2. That's fourth quadrant. So that is negative. So here's kind of the big idea, if I can kind of scrunch it back. is where f prime of x changes from negative to positive, that's going to be a relative minimum. So watch what we're going to do. Change colors. And so I know x equals pi over 3. So let's go ahead though and let's do f of pi over 3 and let's do f of 5 pi over 3. Now this is f. So let's remember, here's f. F is up here, okay? This is f of x. So I need to plug in here. And that's going to be 1/2 times pi over 3 minus the sine of pi over 3. So that's pi over 6 minus, well, the sine of pi over 3 is radical 3 over 2. All right, so f of x has a relative minimum at pi over 3, comma, pi over 6 minus radical 3 over 2, because f prime of x changes from negative to positive at x equals pi over 3. Well, let's go ahead and compute f of 5 pi over 3. So I'm coming back over here. So that would be 1/2 times 5 pi over 3 minus sine 5 pi over 3. So that's 5 pi over 6 minus, now that's fourth quadrant. So let's remember our unit circle. So that's going to be negative radical 3 over 2. So let's come back over here and say f of x has a relative max at 5 pi over 3, comma, 5 pi over 6 plus radical 3 over 2, because, now look at your number line, f prime of x changes from positive to negative at x equals 5 pi over 3. All right, so one more time. The first derivative test says this: if you find your critical points, create a number line test, and anywhere the first derivative is changing from negative to positive, there's a relative minimum. Where the first derivative is changing from positive to negative, you have a relative maximum. All right, let's move on to part B. Find the points that are relative extrema of the function f of x equals x squared minus 4 to the 2/3 power. So let's find the derivative. Bring down the power, decrease the power by 1, and then I have to apply the chain rule. So this is going to be 4x over 3 times the cube root of x squared minus 4. Now, I kind of glossed over this on the first one. The domain was 0 to 2 pi on that first one. Here, this is a cube root, so the domain is all real numbers. Okay, so I don't have any restrictions here on the function. But now, remember, a critical point is where the first derivative is 0 or undefined. So the critical numbers, or critical points, would be 0 and plus or minus 2, because the denominator is 0 at 2 or negative 2. So let's make a number line here. And let's test. So let's say we plug in, let's say 3. So I would have 4 times 3 over 3 times the cube root of 3 squared minus 4. I don't really care what the number output is, but I'm wanting to know if it's positive or a negative output. So that's going to be positive. Then let's plug in, say, 1. 4 times 1 over 3 times the cube root of 1 squared minus 4. So that's positive in the numerator, but in the denominator, can you tell that's actually negative? Okay, let's plug in, let's say, negative 1. So my numerator's negative and the denominator's negative, so that's positive. And let's suppose we pick negative 3. So my numerator is negative, it's negative 12, and down in the bottom, that ends up being positive. So a negative divided by a positive is negative. So can you tell that I need to compute f of negative 2, f of 0, and f of 2. Those are all going to be relative extrema, and I'll identify what they are later. So if I plug in 0, that's negative 4 to the 2, that's negative 4 to the 2/3 power. So that is the cube root of 16. If I plug in 2, oh, that's nice, that's 0. And if I plug in negative 2, that's 0. So here we go. F of x has a relative minimum at negative 2 comma 0 and 2 comma 0, because, let's come back over here, at x is negative 2, my first derivative changes from negative to positive. And at x is positive 2, the first derivative is changing from negative to positive. So f of x has a relative minimum at negative 2 comma 0 and 2 comma 0 because f prime of x changes signs from negative to positive at both x equals negative 2 and x equals 2. Now f of x has a relative maximum at 0 comma, and you could, if this were calculator, you could certainly give a decimal there. So f of x has a relative maximum at 0 comma the cube root of 16 because f prime of x changes signs from positive to negative at x equals 0. So again, look right here at our number line test. All right, letter C. Find all points that are relative extrema on the function f of x equals x to the 4th plus 1 over x squared. So let's do the derivative. So I'm going to do my low d high minus high d low over low low. So that's what? 4x to the 5th minus 2x to the 5th minus 2x over x to the 4th. So that's 2x to the 5th minus 2x over x to the 4th. Let's multitask here. If I pull out an x in my numerator, that would be 2x to the 4th minus 2 over x cubed. I could factor one of those out. And I can factor out the 2. So can you tell? I think maybe I can jump here now to my critical numbers or my critical points. So my critical numbers are going to be 0 and plus or minus 1. Now, that's going to be interesting is if we come back up here, my domain x is not equal to 0. So this one is actually not a critical number. However, when I'm doing my number line, Do you understand that on the graph I do have something's happening here? If you look at the original function, I have a vertical asymptote at x is 0. So I do want to include that because the vertical asymptote is some sort of a break in the graph. So let's do our number line test into f prime of x. So I'm going to do this one mentally. If I plug in, say, 2, that's positive. If I do 1/2, that's negative. If I do negative 1/2, that is positive. And if I do negative 2, that's negative. So let me real quick do f of negative 1, which is 2, and f of 1, which is 2. I'm not going to do f of 0 because it's not part of the domain of f of x. So f of x has a relative minimum at negative 1, 2, because f prime of x changes signs from negative to positive at x equals negative 1. F of x has a relative maximum at 1, 2, because f prime of x changes signs from positive to negative at x equals positive 1. All right, so here are the three graphs from A, B, and C. So you can see your slopes and how they are changing. Pretty cool. All right, let's look at 5.5. It says using the candidate test to find absolute extrema on a closed interval. Now let me pause here a moment and let's look back. These were for relative extrema. Okay, these were relative extrema. So in a neighborhood, we were looking for what was the highest value in the neighborhood. Now we're shifting gears to learning how to find absolute extrema on a closed interval. So in the green box, here's the guidelines. To find extrema of a continuous function f on a closed interval a comma b, you're going to use the following steps. Number 1, find the critical numbers of f in a comma b. 2, evaluate f at each critical number a comma b. 3, evaluate f at each endpoint. So step 2 and 3 really are the candidate's test. Step 4, the least of these f values is the absolute minimum, and the greatest is the absolute maximum. Note, the actual maximum or minimum value is a y value. Where the maximum or minimum occurs would be the x value. So look at example 1. Find the absolute, so now it says absolute. Okay, we've got to be real careful. So I want to do f prime of x, which would be 12x cubed minus 12x squared, and I'm going to set that equal to 0. There's no issues on my domain, so my critical numbers are 0 and 1. So I want the absolute extrema. So the candidate's test says this. You're going to check f of 0, f of 1, and you're going to check the endpoints. Let me say that again. When you are trying to find an absolute extrema, you can use the candidate's test, where you find the critical numbers and you evaluate f, not f prime. So if I plug that in, I get 0. And remember, here's f of x. This is where I'm going to plug into. All right, then plug in f of 1. What do you get for f of 1? If you said negative 1, you are correct. What do you get for f of negative 1? I got 7. Hopefully you got 7. And then let's do f of 2. I got 16. All right, so looking at these 4 values, the largest value is the absolute maximum. So I have an absolute maximum of 7 at x equals -1. The absolute minimum is the smallest y value. So the absolute minimum is -1, and it occurs at x equals 1. All right, I actually have the graphs below, so we'll come back to those later. Letter B. Let's go ahead and now, do you notice this says find, well, we're going to find the absolute extrema. So we're going to do the derivative. F prime of x would be 2 minus, when you bring down the power, the 3's cancel, and I get 2x to the -1/3. So this is 2 minus 2 over the cube root of x. So I could, I suppose, factor out the 2. That really does not matter. So where is this? This is undefined. So f prime of x is undefined at x equals 0. And f prime of x equals 0 at x equals 1. Do you see how I got that? Because if you plug in 1 here, that would be 1 minus 1 is 0. All right, so let's go ahead and do the candidates test. So my critical numbers were x is 0 and x is 1. So we're going to do f of 0, f of 1, and then we do the 2 endpoints. So f of 0 is 0. F of 1 would be -1. F of -1 is -5. And f of 3, this one's a little bit tricky. This would be 2 times 3 minus 3 times the cube root of 3 squared. So that's 6 minus 3 cube root 9. Can you tell that that's just a little bit less than 0? It's just a little bit less than 0. So that then doesn't impact at all in what I need to do. My absolute maximum is here, and my minimum is here. So let's we'll write this down below. So I would say f of x has an absolute max of 0 at x equals 0, and f of x has an absolute minimum of -5 at x equals -1. Then you will see, there I did the graphs for you. So it's really, really cool, especially in letter B. Do you see this? At 0, you can see where the derivative is undefined. Like, cool, super cool. And then you can see the derivative is 0 at x is 1. Like, whoa, that's cool, cool beans. All right, let's finish this up then. In example 2, finding the minimum maximum velocity and acceleration. So we're going to circle back to this, and you will notice we're going to come back to velocity acceleration all year. A particle moves along a straight line with s of t is given for the time interval 0 to 3. Find the minimum and maximum velocity of the particle on the interval 0 to 3. So let's go ahead and find the velocity function. So that's 4t cubed minus 12t squared plus 12t. And I want to know when that is 0. Actually, I do not want to know that. Hold on. Let me do a quick erase. Okay, if I want to do the minimum and maximum velocity, I need to know the derivative of the velocity, don't I? I'm like, whoa. There we go, just caught that. Okay, if I want, let me say that again. If I want the minimum and maximum velocity, then I need to find the derivative of the velocity. Now I'm cooking. So I'm going to factor out the 12. And this is going to factor beautifully. So t equals 1 is a critical number. Now I am going to go plug it back into the velocity function. So I'm going to plug in v of 1, but I need to plug in v of 0 and v of 3. So v of 0 is easy peasy. That's just negative 20. Or, whoops, sorry, went in the wrong one. Gee whiz. Okay, sorry, v. I'm in the v function. V of 0 is actually 0, isn't it? All right, I'm going in here into the v function, velocity. Then let's plug in 1. What do you get for velocity at 1? If you said 4, you're doing great. And go ahead and plug in 3 and tell me what you get for the velocity at 3. I got 36. So we have a minimum at 0 and a maximum at 3. So the minimum velocity is 0 at x equals 0. And I have a maximum velocity is 36 at x equals, whoops, those are not x's, are they? Those are t's, t, t, t. There we go. All right, now to do the minimum and maximum acceleration. So we did the acceleration is right here. So that's the 12t squared minus 24t plus 12. So to determine the minimum and maximum acceleration, we need to do the derivative of acceleration and find the critical number there. So t is 1. So we need to do a of 1, a of 0, and a of 3. And here's our a function. So a of 0 is 12. A of 1 would be 0. And go ahead and find a of 3. What'd you get? I got 48. So I have the minimum acceleration is 0 at t equals 1, and I have a maximum acceleration is 48 at t equals 3. All right, there you have it. Not too bad.